All right, we're going to start here today. So today, this is Earth Science. This is 1.6 observations and experiments, two more parts to the scientific method. So let me move on from here. Let's look on down. Okay, so we've talked about a hypothesis, right? It's an educated explanation to observations. And then how do you test a hypothesis? Well, you make an observation and then you kind of make a statement as to explaining why what you just observed occurred. And you can make more observations, you perform experiments, and then with the data that is collected, then you go through the whole process determining whether the hypothesis was correct or not. So to test the hypothesis, you're going to need data. And how do you collect the data? Well, like we said, by more observations or by running experiments. Now, there's all sorts of equipment available to run experiments. Now, here's an interesting thing. We could say rising temperatures are causing glaciers to melt. And you'd say, well, what do I have? Well, your observations are down here. This is a glacier, I believe in Greenland, I believe. Yes, and just showing how it's been receding over time. So over time it was here, and now it keeps getting smaller and smaller. So that's a bird's eye view from the satellite. Scroll down here now, experiments. So answering some of the questions requires experiment. Experiment simply is a test that you perform actually in the field, which means actually at the site of where it occurs, or in a laboratory setting. Now, experiments must always be done under controlled conditions. And the goal of the experiment is to test a hypothesis. So let me just do this. Answering some questions requires experiment. Experiment is a test that is performed in a laboratory. It's under controlled conditions. And it's to test the hypothesis, and then the data that comes from that experiment will either verify that it's correct, that the hypothesis is correct, or it'll falsify it. But like we said, either way, you're getting answers. Now, in an experiment, it's important to change only one factor at a time, and the what we call the factors or are called the variables. So in an experiment, this is very important. You change only one factor. All the other ones will be kept the same. Those are controlled variables. Now, the one thing that you're studying or you're trying to figure out is the independent variable. The independent variable is the one that's going to be changed, okay? We also sometimes call that the manipulated variable. So that's going to be the one thing that's different between the experimental group and the control group. Experimental group means it's the group that gets receives the independent variable, and the control group doesn't. That's the only thing that's different between the two groups. Okay, so your experimental group, control group. The experimental group will receive the independent variable. Now, we want to find out if it's causation. If this happens, it causes this. All right, if cause and effect. Now, the way we measure the impact of the independent variable is called the dependent variable. Okay, the dependent variable. It depends on the independent. It's also called the responding or the reacting variable. So this is the manipulated one, and then this is the responding variable. Okay, put those in blue. Okay, now, as I said, in an experiment, you must have a control group. And the control group, everything is exactly the same. However, the most important part is it's not subjected to the independent variable, meaning it does not receive the independent variable. Okay, so here's an example. They say that you want to test if vitamin C prevents colds. You'd gather two large groups of people to be in your sample group. Then you divide that group into two groups. That's your experimental and your control group. And then what you do is some will receive the vitamin C. That would be the experimental group. And the others that do not receive the vitamin C is the control group. Okay? Vitamin C is the independent variable. So the experimental group always receives the independent variable. The control group does not. Okay? That's the only thing that's different. Now, it's interesting in all of this, both groups would still receive, a lot of times they would receive a tablet, right? So the experimental group would get the vitamin C tablet, and the other group would still get a tablet, but it would just be placebo. It would just be a sugar pill. And that way, because sometimes people have the placebo effect, and they believe, like, once they're getting something, a pill, even if it's not has no medication, sometimes the mind is extremely powerful, and people can actually have some positive effects, and it's more mind over matter. So that's called the placebo effect. That way, both groups get it, and then you can tell if it truly is due to the medication rather than just the placebo effect. So that's how you do it. And the key thing, like we said, is you only change the one variable. So example would be this. You have your control, you have experimental. The experimental group gets the vitamin C tablet, the control group doesn't. Everything else, all the other variables, all the other are the same. They're all the same. Now, here would be a problem. Let's say the group that gets the vitamin C tablet also consumes more water. We tell them to consume like 6 10-ounce glasses of water every day. We know, right? We know that the more fluid you consume, a lot of times that helps prevent colds too. That's a good thing. It flushes out the body. So the problem with that would be if you're telling the experimental group to take the vitamin C and you're asking them to take water every day. Let's say the results come in and it shows the group that received the vitamin C were less likely to get colds and sick. Well, how would you know if it was the vitamin C tablet that prevented the colds, or was it more water? Was it the 6 glasses of water every day? You wouldn't know. You see that how that's the problem? So you isolate just one variable, that's called the independent variable. And then if there is a difference between the two groups, the experimental group and the control group, you can say unequivocally, easy for me to say, right? It was due to the vitamin C tablet. All right, I'm gonna roll down here. They also talk about how there's human error, and so that'll be built into the experiment. So here in summary is this. When you're testing a hypothesis, it requires data, and the data is either gathered by observation or by experiments. Observations can be done simply by looking or measuring a phenomenon. They also can be using more advanced technology. Experiments must be well designed. They must be under controlled conditions, meaning everything's the same, except for the one variable that's manipulated. And we call that the independent variable, also called the manipulated variable. And then errors we know are part of happen. And so that's why we have this experimental error. Let me get rid of that. My bad. Okay. All right. So hopefully that makes sense to you. Now what I would like you to do is do the practice down here. Let's do this practice. And then after you get 10 right, turn it in and mark it complete on Google Classroom. All right. Thanks so much. See you soon. Bye.